Dominica State College Math 121 Final Assessment, Section A, Practice Questions. It says, number 2, the students patronize 4 snack booths according to the following distribution. There seems to be a factor affecting the manner in which they patronize the booths. You are given the task of testing the following hypothesis. There is a factor affecting the manner in which the students patronize the snack. So that is the hypothesis. So we have to use a chi-square test for randomness for this. We are given the critical value and we are given the data. As you can see, 100 students went to A, 50 went to B, 78 went to C, 65 went to D. So we need to go to the weekly notes number 9 to see how we can perform a chi-square test for randomness. So we go to Google Classroom code CI3QYBO. We go to classwork and then we go down to weekly notes. We can use the PDF version. Weekly notes number 9. Hypothesis testing, and we are going to look for the steps for a chi-square test or using the critical value approach. Here we found the general steps. The first step is to state a pair of hypotheses. For the chi-square test for randomness, this test deals with the verification of the randomness or not for one distribution or set of values which are the observed values. So the H always saying the distribution is random or could due to chance, and the alternative saying the distribution is not random, a factor or factors affecting the distribution. So let us customize this now to our example, number 2. So as you can see, we have stated our HO, which says that there is no factor affecting the manner in which the students patronize the booth, so they when they randomly occurred by chance, and the alternative statement, which is the claim saying that there is a factor affecting the manner in which the students patronize the booths. So that's step number 1. Step number 2 says sketch a distribution curve. For the chi-square test, it will be skewed to the right. Step number 3 says to locate and shade the critical region. For the chi-square test, the critical region will always be on the right side of the curve. And for step number 4, it says to place a critical value on the critical point. So we have to plot this critical value on the critical point, which is also on the right side of the curve. So let us do that. So here are steps number 2, 3, and 4. Here is the curve, the critical region, which is skewed to the right. The critical region is on the right, and the critical value is on the critical point right here, and we have 0 at the beginning. Step number 5 says we've got to calculate a test statistic using a formula, and for the chi-square test, for any chi-square test, it is a sum of the O minus E all squared divided by E, where O is the observed values and E is are the expected values. Now, if we look into example 9.5 for chi-square test for randomness, the expected values now, remember you got given one set of values which are the observed. So the expected values now will be the average of the observed values. You've got to add up the observed values and divide by the number of values. So that's how you calculate the expected values for chi-square test for randomness. So we got our expected values in this example to be 73.25. So here we are using Excel to help us calculate the chi-square test statistic. Here are the observed values, and here is the expected value, which is 73.25. And here we've got our first chi-square contribution, O minus E all squared divided by E. Here it is, A2 minus B2 all squared divided by B2. And we drag the formula all across, and we find the sum thereof, and this will give us our chi-square test statistic. So 18.39 is our chi-square test statistic. Step number 6 is to plot the test statistic on the distribution curve. You must look at the value of the critical value in order to plot the test statistic on the correct position on the number line of the curve, because the curve will already have the critical value. and 0. So we've got our origin, which is 0, and we've got our critical value, which is 11.345 at the critical point. So logically, 18.39 will be more towards the right on the number line of 11. So here we have our test statistic, and you can see it is located in the shaded region because 18 is more than 11. Decision time, step number 7. It says to reject the null if the test statistic is located in the rejection region or shaded region, and do not reject the null if the test statistic is located in the unshaded region. Two types of errors can be made. The type 1 error occurs if the null is rejected and when it is true, and type 2 error occurs if the null is not rejected when it is false. So our test statistic is in the critical region, 18 is more than 11, so therefore we have to reject the null statement. So once we have rejected a null statement, it may be that we have committed a type 1 error. We rejected null, but it could have been true. Okay, we will not know because we are making our decision based on the data values. Okay, but it may be that we have committed a type 1 error because we have rejected a null and it could have been true. And the reason why we rejected a null in this example is because the test statistic of 18.39 is in the rejection region. So we have written our decision to reject the null hypothesis. This hypothesis there, we have rejected it. Step number 8 is conclusion time. If the null is rejected, then the alternative statement is the conclusion, because once you reject the null, you are left with the alternative, so it will be the conclusion. But if the null is not rejected, then the null itself is the conclusion. Always remember that you will start the test with 2 statements, the null and the alternative. After the test is done, only one will be the conclusion. Write out the conclusion in worded form. So we have rejected the null statement, so the alternative is our conclusion. So we have to quote the alternative statement as our conclusion. So for the conclusion, we begin by saying, based on the data, there is a factor affecting the manner in which the students patronize the booths, which is in concordance with what the claim was in the first place. So here is the solution for number 2, which is a chi-square test for randomness.